In question 2.2, we've been asked to simplify to a single trigonometric ratio without the use of our SAC rekenaar. So we analyze things one thing at a time. So I'm going to direct my focus on this tan of 225. So if the angle is bigger than 90 degrees, I definitely want to reduce it with my cos diagram. And 225, let's have a look where that fits in. It's bigger than 180 but smaller than 270, so it fits in the 180 plus quadrant. So I'm going to expand 225 to 180 plus 45. And if you're having a little bit of trouble getting that 45, you can just say 225 minus 180 on your calculator, and it will pop out that 45 for you. Okay. Next up, we're going to chuck that minus over there, just like that. And then we're going to focus on the sign. And then it's sine of 180 plus theta, which places it inside of this quadrant. And in this quadrant, only tan is positive, so sine has to be negative. So that's going to change to negative sine theta. And then just wrap that in a bracket, my bro. And it's starting to look simpler already after I change that sign. Okay, now we're going to deal with this cos of theta plus 90. And when I see a theta plus 90, the alarm bells are going off, my bro. Cofunctions. So I've got to find cos of theta plus 90. So it's not that one, not that one. Hey, how's it? Cos of theta plus 90. Okay, and just before we use this cofunction, you can see here they wrote it like kind of in the wrong order. Theta plus 90 doesn't quite match up with this. But just remember the order of addition does not matter. So imagine theta was 20. 20 plus 90 is 110. 90 plus 20 is 110. So you get the same outcome either way. So you can swap these around quite freely. And now we're going to change this guy using our cofunctions, and he's going to change into a minus sine theta. And just remember, always wrap it in brackets, my bro. Okay, once we've dealt with that guy, we're going to move on to this sine theta. That's simplified as far as it possibly can be. So he's going to stay behind. Okay, and then the sine of 360 plus theta. I don't have 360 plus in my reduction diagram or my cos diagram. So how we make this thing normal is we do the following. Subtract 360 degrees. So 360 minus 360, that 360 just disappears. It gives me 0. And I'm just left with plus theta. So inside this bracket, we're just going to get a simple sine theta. And I like to wrap both of these guys in brackets to help remind myself that I'm multiplying them. And then we just put that plus over there. And now we're going to focus on this cos theta. It's been simplified all the way, so it just stays. And then lastly, we have to deal with this cos of minus theta. There was a little bit of a mistake at the beginning of the question, but I have fixed it up since then. So how we normalize it is we add 360 in there. And what that does is it changes it into cos of 360 minus theta. So it sets me up beautifully for reduction in the next step. Okay, now we're going to go one by one again and sort these things out. Okay, so having a look at tan here. Tan of 180 plus. That puts us in the 180 plus quadrant. And tan is positive there. So that's going to change to positive tan of 45. Okay, and then I'm going to keep that minus over there. And then minus sine theta times minus sine theta. A minus times a minus is a positive. Sine theta times sine theta is sine squared theta. Okay, now we've successfully sorted the top out. Now we're going to go to the bottom. Sine theta times sine theta is sine squared theta. And then I'm going to keep that plus cos theta next to it because I want to sort this out first. And cos of 360 minus places us in this quadrant, and cos is positive over there. So this is just going to change to cos theta. Okay, we are starting to inch our way closer. Tan of 45, I smell a special angle. And this is also a clue without using a calculator. So I've got to get my special angle triangle. Okay, so if I have a look at my special angle triangle with the 45 degrees, I'm going to be getting toa from Sokotoa. So it's basically going to be the opposite over the adjacent. So opposite the angle is root 2, and adjacent the angle is root 2. Adjacent just means next to. So it's going to be root 2 over root 2. And that minus sine squared theta at the top can stay. There's nothing really I can do to that just yet. Okay, at the bottom the sine squared theta can stay. And then cos theta times cos theta is cos squared theta. Okay, and then I smell a few identities coming our way. Right, so I'm just gonna zoom out a little bit and then we can carry on. But okay, any number divided by itself will be 1. And you'll see the calculator agrees with me. Yourself. And then at the bottom here, I'm smelling an identity. Cos squared plus sine squared theta is equal to 1, my bro. So I can change the bottom to 1. And then I'm also smelling an identity at the top, bro. 1 minus sine squared. 1 minus sine squared. It's going to change into a cos squared. Again, we're almost done. Anything over 1 is just itself. So like 7 over 1 is 7. So cos squared over 1 is just cos squared. And yeah, we are done. Yes, this test did a lot of things. This was a park down prawn if I've ever seen one, but let's have a look where the 1700 marks come from. The first mark comes from your reduction of the sine into minus sine theta. Second mark comes from the cofunction. The third mark comes from this sine theta, how we changed that by subtracting 360. And the fourth mark comes from adding in that 360 and then getting a cos theta. Fifth mark comes from that little 1 over there. Engine number 1. And then the last mark comes from cos squared theta.